So first of all, welcome back everybody. We hope you had a nice summer break. Thank you for joining us today for this first September webinar. Make sure you check out the other three scheduled for this month. Today we will dive into MISRA Compliance and Legacy third-party code. As usual, this is Lavinia, CSR at BUGSENG, and our speaker is Roberto Bagnara, who, long story short, is CTO at BUGSENG, computer science professor at the University of Parma, member of the MISRA-C working group and of the International Standardization Working Group of the C programming language. A quick note before we start, please feel free to write all your questions in the Q&A section throughout the entire webinar. We will read them and reply at the end. All right then, let's turn this over to Roberto.
Okay, so welcome back also on my part. So first, a disclaimer, I am a member of the MISRA-C working group. However, the views that I express in this presentation are mine and should not be taken to necessarily represent the views of the working group. And another disclaimer, the decision about what to deviate and how to deviate is really project dependent and requires a careful balancing of difference and sometimes competing objectives. So deep knowledge about the project at hand is required in order to decide what to deviate and how to deviate. So in this presentation, I make examples that may or may not apply to your situation. So here is the outline of the webinar. I will start with some introduction. I will then introduce adopted code, and I will need to provide you a quick recap on deviations because we will talk about deviation in the sequel. And we will go through some specificities of adopted code with respect to MISRA compliance. And then I will present three tactics for dealing with adopted code. And then I will draw finally some conclusion. So let's start with the introduction. This webinar is in a context. It builds upon several previous webinars. So first one, MISRA-C and its key role for the compliance to industrial safety standard, is the webinar in which I have tried to convey the main things about MISRA-C. We had a webinar about MISRA Compliance 2020 for project managers. Another webinar has been MISRA Coding Standard and the Art of Deviation. And as I said, deviation is so important that I will provide a brief recap in this webinar. Implicit conversions in C, the hidden enemy, which was followed by the essential type model of MISRA-C 2012. So I tried to make this webinar as independent as possible, but if you miss something, you can find all the webinars mentioned in these slides on our YouTube channel. And I encourage you to subscribe to make sure you do not miss any future editions. Notice that the main ingredient of the YouTube channel are the recordings of webinars, but there is also other material that does not correspond to any webinar. Okay, so MISRA Compliance 2020 is the document that describes what must be covered in order to make a proper claim of MISRA compliance. This document, which you can download from the MISRA website, is applicable to MISRA-C 2012, all revisions, and also to MISRA-C++ 2008. For the time being, its adoption is optional, but it will become mandatory with the next edition of MISRA-C and MISRA-C++. And Chapter 6 of MISRA Compliance 2020 deals with adopted code. So what I will cover in this webinar is partly derived from Chapter 6 of MISRA Compliance 2020. So adopted code. As you noticed in the title of this webinar, the word adopted was not present because I didn't want people not familiar with the official MISRA terminology to be misled. So in the webinar title, I mentioned legacy code and third-party code, and this is good part of adopted code, but there is more adopted code. So adopted code in MISRA Compliance 2020 is typically derived from the standard library. The standard library is very often provided with the compiler. Device drivers, they are usually provided with the compiler or supplied by the hardware manufacturer. Middleware components, such as operating systems, real-time frameworks, and protocol stacks. Third-party libraries, graphical libraries or mathematical libraries. Automatically generated code, code that is automatically generated by modeling tools, and legacy code, code developed for other projects or previous versions of the current project. And code that is not adopted in MISRA parlance is called native code. So adopted code is what you take from outside the project, and native code is what you develop for the present project. So let's start with the poll. What do you think MISRA compliance, the MISRA compliance document says about adopted code? So there are several possible answers. Maybe you think that adopted code can be disregarded, so you don't even need to analyze it, or adopted code needs to comply, or need to comply to a lesser extent, or adopted code except the standard library needs to comply, or adopted code needs to comply, full stop.
Okay, so we've got 26% adopted code needs to comply to a lesser extent, 12% adopted code except the standard library needs to comply, and the majority, 64%, adopted code needs to comply, full stop.
Okay, so I am happy nobody thinks that adopted code can be disregarded and you don't even need maybe to analyze it. So the more correct answer is the last but one. So adopted code except for the standard library needs to comply. So let's see what is the bottom line, what is the idea. So the idea is that even in presence of adopted code, the safety and security of the overall system has to be ensured. So this really is a non-negotiable requirement. And quoting literally from MISRA Compliance 2020, this document says that the impact of adopted code on the integrity of the system must never be overlooked or assumed to be benign. There are two distinct issues to consider. Has the adopted code been developed to a verifiably adequate level of safety and security? Question one. Question two, has the adopted code been developed to be compliant with MISRA guidelines? These two issues are not equivalent. Compliance with the MISRA guidelines is neither a necessary nor a sufficient condition to ensure the quality of adopted code. So this is a very important thing to be taken into account. Now, how can you decide if code is native or adopted? So the point is that it makes sense to consider code adopted only if it is existing code with a proven track record. So it's code that has been running in its present form for maybe 10 years, 20 years without any serious problem. So it has a proven track record. It has been assessed to be fit for purpose, which means that it is good as it is. You need not changing it. And also, as a consequence of the first 2 points, the risk involved in changing this code outweighs the risk of leaving it as it is. So you don't want to change it, okay? It is upon these conditions that it makes sense to consider code adopted. And in particularly, if you take some code from a previous version of the project or from your company and you adapt it, okay, this is not adopted code. It should be considered native code. So, a rule of thumb, in order to decide whether you can legitimately consider a piece of code as adopted, the point is you have good reasons to consider it adopted code only if you have good reasons for not wanting to change it. Okay? So this is very important. Now, let us move to the next section in this webinar. So a quick recap on deviation. As we have explained in the webinar that we devoted to deviation, The deviation process is the procedure by which justifiable non-compliances can be authorized and recorded. So the exact process is not imposed by MISRA Compliance 2020 because methods used will vary between organizations. But MISRA Compliance 2020 imposes constraints on the process. So see the webinar MISRA Coding Standards and the Art of Deviation on our YouTube channel for more on this subject. Another important point is that justifying a deviation is only legitimate for some reasons. And in particular, deviation should not be permitted just to satisfy the convenience of the developer on when a reasonable alternative exists to avoid the violation, or without considering the wider consequences of a violation on other guidelines, or without the support of suitable process, or without the consent of a designated technical authority. And in particular, the document MISRA Compliance 2020 explicitly says that a deviation should only be approved if it can be justified on the basis of one or more of the following reasons: code quality, access to hardware, and the last two specifically mention adopted code. So adopted code integration and non-compliant adopted code. So in this webinar, we will focus especially on the last two reasons. Okay, so adopted code is special in the sense that it poses additional problems to MISRA compliance. So first thing, as in the webinar concerning MISRA compliance, we have explained that there is the possibility, and it is actually very much recommended for the acquirer and the supplier of the code to agree upon one or more guideline recategorization plans, GRP. So according to a GRP, the category of guidelines can be remapped. In particular, mandatory in reality can only remain mandatory. Mandatory are non-negotiable. The required guidelines may be upgraded to mandatory, and the advisory guidelines may be upgraded to required or mandatory, or they may also be downgraded to disapplied. When you have adopted code, typically you will use multiple guideline recategorization plans. You will have one for the native code, the code you are developing specifically for this project, and you will typically have one or more for different portions of adopted code. So a given piece of adopted code should have its own GRPs, not because MISRA says that, but because it is convenient for you to have it. So, for example, one of the recommendations I will give will be to disapply the violated advisory guidelines. And you may want to do it with good reasons on adopted code, but you may not want to do it for native code. So adopting multiple GRPs is a good thing that MISRA Compliance 2020 allows you to do. Another thing to be understood is that there are guidelines. We have seen them in the webinar introducing MISRA-C that have a system-wide analysis scope, meaning that in order to decide whether the project is compliant or not, you have to analyze the entire system. Well, this is relevant because in case of adopted code, your system is composed by an adopted part and a native part. And so what may happen is that the combination of compliant translation units can be non-compliant. And in the case of adopted code, this is made even worse. Because if they are all native code, then you may change the code in order to remove the violation. So you modify the code and you remove the violation. But when adopted code is involved, then it may be necessary to raise a deviation. And this, you can do it in accordance with the reason adopted code integration. the point is that in order to work effectively on projects that contain both adopted code, possibly different components of adopted code and native code, then you need a considerable sophistication in the tool. So the tool should be able to easily support the differentiation between adopted code and native code. So I will come back to this point soon. There is also the possibility of adopting binary code. So in some cases, the adopted code is binary. So if the code is only available in binary form, MISRA compliance is not fully verifiable by the acquirer. So what might happen is that the supplier gives you an issue, gives you a statement of MISRA compliance. So a declaration that the code the supplier is selling to you has been developed to comply with the MISRA guidelines. It can, ideally, it will give you a GCS, so a guideline compliance summary. If you want to know what it is, go on our YouTube channel and look at the webinar about MISRA compliance. And in this case, you are done. But otherwise, if you have adopted code without a statement of MISRA compliance, then MISRA compliance for the overall project simply cannot be achieved. This doesn't mean that the project is not good. Doesn't mean that the adopted binary code is not good. Maybe it's very good. Maybe you also have a very extensive test suite in which you can prove, with which you can prove that the code is very good, but simply it will not be MISRA compliant. So MISRA compliance requires a certain process to be followed, and you either have to have the code yourself so you can make the check, or someone with the source code available may be able to do the check and provide you with a suitable statement of compliance. For adopted source code, the point is that violations cannot be ignored. So every guideline violation needs to be reviewed, and as changes have to be avoided or limited to provably safe one, suitably justified deviation will have to be raised. So you don't want to change adopted code unless you can easily prove that the change does not cause any change of behavior. And so you will have to raise justified deviations. And you, of course, have to hope that no mandatory guidelines are violated, because, as I told you, mandatory guidelines cannot be deviated. So if mandatories are violated, you are in trouble. So we'll see that in some cases we can have a solution to go out of trouble. So now let's move to the issue of adopted header files. So it's a very common case in which the adopted code header files are included in native code modules, of course. Okay. And it is very important to understand that the problem might be in the header file. So it may be a problem in the adopted code, or it may be in the native code modules. I prepared an example. So I have an header file called adopted1.h that defines a macro is null of x, and which returns the evaluation of the quality test between x and 0. And then I have a piece of native code which includes the adopted code and calls is null with a pointer. Well, there is a rule 11.9 in MISRA-C 2012 that says that the only valid form of null pointer is the macro null, N-U-L-L, written in all capitals. So 0 is not a legitimate null pointer constant. So this is a violation. But where is the violation? The violation is not in the adopted code. It's true, the macro is defined there, but there is nothing here that says that you have to use it to test for nullness of pointers. So the problem is in the native code. The native code should not use this macro to test for nullness of pointers. So the thing is more complex than this. So this might suggest that, okay, here you don't call is null. You have your own macro. For example, you may call it is null pointer or anything like that. However, in some cases, the adopted code may be more convoluted. Okay, in particular, the adopted code might have the macro is null and use it in order to test for the nullness of a pointer. So as this is adopted code, I don't want to change it. So I will have to deviate rule 11.9 for the adopted code, but this does not give me rationale to deviate 11.9 on native code. So this invocation of the macro is okay. This invocation of the macro is not okay. So, and here comes the importance of having a tool that allows you to treat differently different parts of your project. So here I have a given example of the configuration language of Eclair, where in the first line, I associate a tag adopted. This is just any string. I could have chosen any other string. I've chosen adopted. And I say that adopted2.h is adopted code. Okay? And then I configure the checker for MISRA-C 2012 revision 1, rule 11.9, so that I hide all the invocation of the macro is null that are expanded from adopted code. So this is okay, because here the macro is null is expanded from adopted code, because this is part of the adopted code, whereas this is not good, because here the macro is expanded from code that has not been tagged as adopted. Okay, the standard library. The standard library is special. It's an integral part of the language implementation. It is defined in the C language standard, and the same for the C++ standard library. And its implementation, including the header file, can really do anything. And in fact, as it is usually developed together with the compiler, it can exploit implementation-defined behavior, unspecified behavior, and even some undefined behaviors. Not only this, in some standard library implementation, the header files of the standard library can also use syntax that is not C. The compiler has ways to know when it is parsing a standard library header file and do different things. So because of this, and because of the fact it can be assumed that the standard library has been tested thoroughly. For example, if you do compiler qualification, typically the compiler qualification test suite, if it is a good one, it will test the standard library very thoroughly. So you can assume correctness. And so the C standard library is explicitly exempted from complying to the MISRA guideline. So this is explicitly said in the MISRA compliance document. So the C standard library is adopted code, but it needs not to comply to the MISRA guidelines. So in this sense, the most accurate answer was the last but one in our poll. Okay, so let us move to the section of the webinar where I will present 3 tactics for dealing with adopted code. The first tactic is called exchange mandatory with required or advisory. Okay? So what do I mean? The point is this: when a mandatory guidelines is violated, it's a disaster. So if it is a false positive of the tool, then we have to prove it, and this may happen. So the tool says you are violating a guideline, which is mandatory, but the tool is wrong. So you have to build an argumentation explaining why the tool is wrong, and so this is no longer a violation. So good. But if you are unable to do this, then we need to change the code. But we said that we don't want to change adopted code. Okay. The point is that we need to compromise. So we want to have MISRA compliance. We know we can have MISRA compliance, but we can only achieve it if we make some changes. Well, the point is that these changes should be minimal and they should be accompanied by adequate guarantees. Okay. And as we will see in an example that will follow, in some cases, the elimination of a violation of a mandatory will cause the introduction of violation for required and or advisory guidelines, but we can deviate them. So it is in this sense that this tactic is called exchange mandatory with required or advisory. So let's start with a mandatory guidelines that everybody knows. So the value of an object with automatic storage duration shall not be read before it has been set. So basically, you cannot read from a stack variable until the point where this stack variable has been initialized, because otherwise it is undefined behavior. So as a violation of this guideline directly results into undefined behavior, it's mandatory. So you cannot deviate it. So let's start with an example. So suppose we have this in adopted code. So here we have a variable, an automatic variable. So it's the stack. It's called X. There is a lot more code here. And this code may or may not initialize X. And the tool says that here we are violating rule 9.1. So according to the tool, X is read without having been initialized here. So the possibilities are, there are basically two possibilities. So you can prove that it is a false positive of the tool. So in your guideline compliance summary, you will record your argument explaining that this is a false positive of the tool, and then you are done. Okay. But if you cannot prove it is a false positive, you will have to change the code. So how can you change the code? The change should be minimal and should preserve the behavior of the program. So one possibility is that you are the initializer. Of course, you want the behavior not to change, so the initializer value should be chosen very carefully. So you really have to understand this more code here in order to make sure that, for example, 0 is a good value for the initializer. Okay. And notice that what may happen when you have added the 0 initializer here is that the tool now flags this initialization with a violation of rule 2.2. So the one that says that there shouldn't be dead code, meaning useless code. So the tool is telling you, hey, you have added an initializer here, and this is redundant. Okay, good. The tool is being inconsistent. So no tool is perfect, of course. This may happen. The tool first, it said that this was read initialized. Now it's saying that this is redundant. If it really is redundant, it is good news, because if it is redundant, I am not changing the behavior of the code. And moreover, rule 2.2 is not mandatory. is required, so I can deviate this. So this is an example where I have exchanged mandatory for required. And the advantage is that now I can deviate 2.2. Okay? Before, I couldn't deviate 9.1 because 9.1 is mandatory. Okay? Good. Another possibility is that I'm not completely sure about the fact that of what is a correct initializer value, but I'm really confident that the code in between here is initializing X. So one strategy I could follow is that I look for a value that X cannot take in this code, which is omitted here in the middle. For example, int32 min, suppose that int32 min can never, X can never take this value in this code that is omitted here. So I initialize it with int32 min, and then I put, just before returning, I put a test. If X is int32 min, it means that nobody touched it. So this value is here because I put it myself. And here I should apply countermeasures. So here at runtime, I will discover that indeed the code were not in some cases, was not in some cases initializing X. So hopefully I will spot this problem during internal testing. So I will think again about this code that is here, or even if this is discovered on the field, I have applied a suitable countermeasure. So here there is code that makes sure that even if this happens, the system is safe. Okay. As I am working on a project where we are trying to understand whether a subset of the Linux kernel can be made MISRA compliant, I have added this example. So in the MISRA kernel, there are several instances of self-initialization. So int32t x equals x. So I have no idea why someone thought it might be a good idea to use this self-initialization in the Linux kernel. However, this is undefined behavior. Okay, so if the idea was that maybe X was not initialized here, adding this makes things worse, because here we have an undefined behavior for sure, and before we had a potential problem. So how do you deal with this? You certainly remove this bogus self-initializations. There are I don't know, a few dozens in the Linux kernel, in the portion of the Linux kernel we considered. So they should be removed and then proceed as in the previous example. So tactic one. The tactic two is exploit through adoption. What do I mean? So let me repeat myself. If it is adopted code, it means that it has a proven track record. It is fit for purpose, and I don't want to change it because of this. Okay, so because this requirement implies that it works as intended, we need not understand its implementation, just the interface. We need not read the code, okay? And we will not change it in ways that can impact its integrity, okay? So this is a good rationale for possible deviations. And now I will go through several examples of this. Okay, so rule 2.1, a project shall not contain unreachable code. Why is this? There are several reasons. So one of the reasons is that maybe legacy third-party code has been designed to be built for different configurations. And I am using this as adopted code in one specific configuration. So I have indeed functions that are never called, for example. Okay, and in this case, the fact that I have unreachable code is not an indication of a programming error, as it is in native code. So in native code, have functions that I never use. So unless I am building a project that also has a multiple configuration in mind, and I didn't make proper use of the preprocessor, this is a symptom of a programming error. So the rationale for this deviation is even stronger if the build process will remove unreachable functions at link time. So depending on the tool chain, and especially on the linker, some linkers will be able to remove functions, for example, that are never called. So this function will not even be present in the executable code. Okay? Avoiding to have executable code that is never used is a good thing from the point of view of security, for example. So, because if the unused code is code for special functions that are not supposed to be used in this project, but they are still in the flash memory of the device, then an attack that is able to divert your control flow may cause execution of the code you didn't want to be executed. So it's much better to not even have it in the executable code. Rule 5.3, an identifier declared in an inner scope shall not hide an identifier declared in an outer scope. So it is required. What is the rationale for this MISRA guideline? Is developers' confusion. So in new code, there is the danger that programmers will be confused about which object is denoted by an identifier, because the same identifier is used for two or more objects. However, in truly adopted code, it's not meant to be read, reviewed, or modified by human programmers. So I will reuse this motivation for several guidelines in the sequel of the webinar. No developers' confusion. So this, the fact that it's adopted code, it means that you don't need to read it, to review it, or to modify it. So when the rationale is developers' confusion, it will be easier to provide a defensible justification for the deviation. Okay? So rule 6.1, bit fields shall only be declared with an appropriate type. The C standards only allow you to have certain types as types of the bit fields. If you declare a bit field of type int without the specification of signed or unsigned, the behavior is implementation defined. And if you use a type that is not supported by the implementation, you have undefined behavior. However, on legacy third-party code, you have just to make sure that the user types are supported by the implementation, okay? And supported by the implementation, including the implementation defined behavior for plain integer bit fields, and then you can deviate the guideline. Rule 7.1, octal constants shall not be used. The reason is developer confusion. So octal is not very much used, and so many programmers do not know if that a leading zero can completely change the value of a constant. But again, if this is in adopted code that works as intended, we don't need to read it or to understand it, so no developer confusion, and we have a rationale for a deviation of rule 7.1. Similarly, for 7.2, so it's a rule that mandates to add a u suffix to integer constants that are implicitly unsigned. Okay, and the reason is that whether a constant is signed or unsigned depends on a quite complex combination of factors, including the magnitude of the constant, the size of the integer types, the number base, so there are different rules for decimal, octal, or hexadecimal, and the presence of any suffixes. But again, as we do not need to read, review, or modify adopted code, no developer confusion is possible. We can deviate this rule. 7.3 is similar, so it's it mandates, it requires avoidance of the lowercase letter L in literal suffix because the lowercase character L can be easily confused with the digit 1. So developer confusion would result, but the developer confusion argument does not apply to adopted code, and we can deviate it. Rule 8.4, it's a compatible declaration shall be visible when an object or function with external linkage is defined. The reason of this rule and of the following one is that when we have two declaration and definitions that are incompatible, this is undefined behavior. And if the compiler does not see the incompatible declaration and definition at the same time, then it will be unable to flag this as a compilation error. Whereas if you comply to rule 8.4 and 8.5, you will enable the compiler to check compatibility. Okay, so for adopted code, the rule can be deviated provided you check that the declarations and the related definitions are compatible. So if you do this check, then you can deviate 8.4 and 8.5. That is the rule saying that an external object or function shall be declared once in one and only one file. These two rules, 8.4 and 8.5, go hand in hand to make sure that the compiler can flag as errors the presence of incompatible declarations and definitions. Okay, so again, the rationale is the same for the deviation of rule 8.4. So you can deviate them both, provided you, in the deviation record, you specify how did you check the compatibility between declarations and definition. The rule 9.2 is another required. The initializer for an aggregate or union should be enclosed in braces. And this is also a rule that is for understandability because it is using properly the brace symbols. You can make it clear what is initialized with what, but again, since adopted code doesn't need to be read, modified, or understood, we can deviate 9.2. Rule 9.3, arrays shall not be partially initialized. So if you provide an explicit initialization for each element, then you make sure that it is clear to everybody that every element has been considered and that you didn't omit the last elements by mistake. However, there is no real problem if you violate this rule. I mean, the elements that you do not explicitly initialize are zero initialized by the implementation. So again, if this happens in adopted code, code that works, code that has a long history of use, so you can assume that the initializations of arrays are okay. And whatever is zero initialized by the implementation is okay, that it is zero initialized. 9.5 is similar. So when you use designated initializer, you should specify the size of the array explicitly. Why there is this rule? Because otherwise, the size of the array is not easy to detect from the source. It's the highest index you use in your designated initializer. And this may not be what the programmer intended. Anyway, as usual, in truly adopted code, there is no risk of developers' confusion. There is a rule, an entire series of rules, so 8 rules that have to do with the essential type model, and most of them can be deviated in adopted code because the reason is developer confusion. So this is true for 10.2, 10.5, 6, 7, and 8. They can be deviated on the grounds that you don't need to read the adopted code, so no developer confusion. Whereas for rules 10.1, 10.3, and 10.4, they can be deviated for the same reason, but you have an additional requirement. You have to rule out the undefined and unspecified behavior that these three rules are meant to prevent. Okay, so you have not to, whereas for the first, for rules 10.2 and 10.5 to 10.8, your argument will simply be there is no developer confusion possible because this code will not be read. For the remaining three rules, you will have to rule out undefined and unspecified behavior and implementation defined behavior, making sure that the implementation defined behavior assumed in the code matches the one used in the implementation. 11.9, we already discussed this at length. So again, no developer confusion is possible. This is the reason of the rule. So the rule wants to make it very clear when a null pointer is intended. Rule 14.2, a for loop will be well formed. So the reason for this rule is that restricting the possible uses of the for looping construct results in code that is easier to review and analyze. This is a motivation that doesn't apply to adopted code, to truly adopted code, so we can deviate it. Rule 14.3, controlling expression shall not be invariant. This is because in native code, having an invariant rule, so you have an if then else, but the condition is always true, is it is possible that this is due to a programming error. However, this invariant value in adopted code, especially code that has been developed with a multiple configuration in mind, the fact that a certain if then else as a guard that is always true or always false may come from this multiple configuration thing of the code. So it's not a symptom of a possible programming error, so we can deviate this one. Rule 15.7 says that if you have a chain of ifs and elses, then this chain should be terminated with the final else to make sure that you didn't omit by mistake the final else. So this is the reason is to improve readability, to make easier to maintain and review the code. As we said, this is a motivation that doesn't apply to adopted code, so we have good reasons to deviate. There is an entire section in MISRA-C 2012 that has to do with the switch statement. For the switch statement has a quite complex semantics. So some of you might have heard about the famous DOCS device. You see that here it is. It's a switch that contains in its body a do-while loop. So this is perfectly valid code. It also makes sense, meaning that this code was designed to satisfy a specific need, but this explains that the switch statement in its full generality can result into code that is very difficult to read. However, we already know this. This doesn't apply to adopted code because we don't have to read it, so we can deviate the entire series 16 in adopted code using this reasoning. Final example, I think rule 18.1, a pointer resulting from arithmetic on a pointer operand shall address an element of the same array as that pointer operand. Okay. Of course, it is undefined behavior if you do a pointer computation that is wrong. However, there are objects that behave like arrays, even though they have not been declared of array type. For example, memory areas at specific hardware addresses. For example, I don't know, you may have the start of the read-only memory, which is provided as an absolute address. And this is not an array, it's not be declared as an array, but it behaves like an array. So in order to deviate this, you should, of course, make sure that each computed memory address and accesses are validated. So if you are able to do this, then you can deviate the rule. Notice that in order to a memory address to be valid, the pointer must point to the array or one past the final element of the array. However, for accesses, the pointer must be in the array. So otherwise, it is undefined behavior. So if you make sure that the computed memory addresses and accesses are fine, then you can deviate the rule. Tactic 3 is very simple. These apply violated advisory guidelines. So as I said, the MISRA Compliance 2020 document allows you to disapply advisory guidelines, and the rationale covers the case of adopted code. So there is no point in checking advisory guidelines on code that was not written to respect them. I may end up with millions of violations for the sake of nothing. So in this case, this application makes sense. But of course, there is no point in disapplying these advisory guidelines to which the adopted code happens to comply with. So that's why the tactic is disapply the advisory guidelines that you violate. If it is not violated, there is no point in deviating it. Okay? It's against your interest, because even for advisory guidelines, the degree of compliance is an indicator of the quality of the code. So why should you disapply guidelines to which you comply? For those that you disapply the rationale has to be written in the guideline recategorization plan you use for this adopted code, and the justification will be very simple. So it will be a sentence explaining that this is adopted code, and due to this, there is no point in checking the guideline. So it's time for the second poll. Before to conclude, do you have any present or future MISRA plan? And do these plans involve the use of adopted code or not?
Okay, so the majority, the 66%, said yes right now, and it involves adopted code. 7% yes right now, but it does not involve adopted code. 7% yes in the not too distant future, and it involves adopted code. 6% now, yes, in the not too distant future, but it does not involve adopted code, and 25% no MISRA projects in sight.
Okay, so it seems that the relative majority is people that is working on MISRA projects that involve adopted code, so which is good. So conclusion. Staff competence is a crucial requirement in order to carry out activities that allow describing a project as MISRA compliant. Some functional safety standards also put requirements on the skills of the software team members. And for project where adopted code is used, MISRA and tool competence is even more important. So since in adopted code, you don't have the option to change the code. So you may have to change in case you have mandatories that are required, but these changes should be very, very, very careful. So for the rest, you will have to produce defensible deviations. And this requires skills significant skills about MISRA and about the tool, because as I said, you will have to analyze the adopted code and the native code with a configuration that, if the tool allows that, take into account the specificity, the adopted nature of the adopted code, still keeping the correctness of the overall analysis. So without a proper understanding of the MISRA guidelines and of the process, especially if you have adopted code, you may end up with a flawed MISRA compliance argument, which is not necessarily a disaster. So as was explained in the webinar about MISRA compliance, the topic of MISRA compliance typically arises at a negotiation phase between the acquirer and the supplier. And if you are the supplier and the acquirer accepts your MISRA compliance argument, then you are okay. Okay, but if you have a flawed MISRA compliance argument, the acquirer may not accept it, and you may be in trouble then. You may be in trouble because there may be penalties, and this may result into a very difficult situation. So for this reason, management of adopted code is really one of the areas in which our consulting services may save you a lot of time and effort. So if you have to deal with adopted code and you are encouraged to consult with us, at least initially, in order to see if we can help you. And typically the answer is yes, we can. So conclusion, we have addressed the topic of MISRA compliance as far as adopted code is concerned. This was the missing bit. So in the seminar, MISRA Compliance 2020 for project managers, we left out the issue of adopted code. Now the picture is complete. So very soon on our YouTube channel, you will have both of them, and you can consider that they will give you a very good introduction to MISRA Compliance 2020. There are several messages to take home. So there are requirements on adopted code, and I'm very happy that our initial poll showed that none of you thought that adopted code could simply be ignored. So there are requirements. So it's not that since it is adopted, you need to do nothing about it. The violation of MISRA guidelines in adopted code cannot be ignored apart from the standard libraries. So this is good news. And there are tactics that may help and to achieve MISRA compliance in the presence of adopted code. We provided 3 of them. However, management of adopted code may still require a lot of energies. Proper training and good tools are even more important if there is adopted code, and this is an area where consultancy services can be recommended. Okay, so if there are questions, I will be happy to try to answer them.
Okay, thank you, Roberto. So first question, let's suppose I have too many violations for a certain mandatory rule. If I decide to apply only minimal changes on adopted code, am I authorized to claim the compliance of code with MISRA?
Okay.
If you need to read it, it's a long one.
It's very long. So yeah, which one is it?
Sorry?
Sorry, it's very long. I was lost in the...
Yeah, it's one of the first. It's in the Q&A section.
Yes.
Do you want me to read it again?
Yes, at least the beginning.
Okay. Let's suppose I have too many violations for a certain mandatory rule. Okay, yes. It's that one.
Yes. No. There is really no. If mandatories are violated, you have no grounds upon which to base any statement of MISRA compliance. So it really is not possible. So as I said at the beginning of the webinar, this is not the end of the world. So code can be of very high quality without being MISRA compliant. So, but if you want to make a proper claim of MISRA compliance, you cannot violate any mandatory guidelines. So that's it.
Okay. Can we have a simple example on deviations using Eclair?
Not in this webinar, but in the YouTube channel, there are several demonstration videos where you can see, let me remember the title. So the title was MISRA Compliance done in front of you in 1 hour.
Watch it on live.
Watch it. Watch it live. Yes, yes. Okay. So there is a webinar in our YouTube channel.
Okay. What if, despite all effort, some mandatory rules are still violated?
Okay, so yes, it's the same question as above. If despite all efforts, some mandatory rules are still violated, you cannot make a claim of MISRA compliance. It's a pity, but it may happen. So.
Okay, we have a very quick question, but the person had to leave. We will submit it anyway, so everybody knows. Have you ever worked with generated code and MISRA Compliance? How you will define a code generated design from a team, adopted code or native?
Okay, so the automatically generated code is adopted code. And the arguments that I have introduced in detail for the general case of adopted code also apply to automatically generated code. So in particular, the fact that automatically generated code is not meant to be read, understood, or modified by humans. So you can certainly deviate many rules on these grounds. However, the question seems to have to do if the how you will define a code generated designed from a team. So I don't understand this question. So if it is generated code, it's adopted. It's not native.
Okay. If a piece of potentially adopted code comes with an extensive test suite, is it easier to adopt it?
Oh, this is interesting. So if a piece of code, of any code, comes with an extensive test suite, is a very good thing, independently. And it's an advantage in any case. If it is, in a sense, it is easier not to adopt it. It's easier to use it as a native code, because you can change it, and then you can run your extensive test suite to gain confidence in the fact that your changes did not change the behavior of the code. I don't know if it's clear. So the fact that you have an extensive test suite is not does not make adoption as adopted code easier. It makes it easier to consider it as native. So you may, of course, postpone this decision until you have analyzed the code. But if you analyze the code and it doesn't have significant MISRA violations, you can consider it as adopted, because you know that it will be an easy matter to maybe deviate the few guidelines that are violated. But even if it violates several guidelines and maybe also mandatories, then it will simply mean that you will not consider it as adopted. You will consider it as native. You can change it, and you can have, using the test suite, guarantees that your changes did not change the semantics of the code.
Okay, thank you, Roberto, and thank you again, everybody, for joining us today. Of course, if more questions come to mind, you can always drop us an email at info@bugseng.com. Same if you want to have a chat about your projects. If you need to comply with MISRA, we are more than happy to guide you through it and provide you with a free trial of our static analysis tool, Eclair. Even more so, if you're dealing with adopted code, bear in mind that we offer very specialized training and consulting services, and that of course we are always at your disposal. The recording of today's webinar will be available very soon on our YouTube channel, which we invite you to subscribe to, as it is full of videos and demos on MISRA, functional safety and other relevant topics. Hold on just a second and let me remind you that next webinar will be about language subsetting and compiler qualification in the development of software for safety critical systems. This will be on September 17th, and we will host Marcel Beemster, who is the CTO of SolidSense, creator of Supertest. So if you haven't already, head over to bugseng.com/webinars and register. All right, that was it from us today. We look forward to hear from you very soon and see you all next time. Bye bye. Have a nice day, everybody.